Aditya L1, India's mission to study the Sun and solar phenomena. Aditya L1 is a significant space mission undertaken by the Indian Space Research Organisation, ISRO, in collaboration with various Indian research institutes. This mission is primarily aimed at studying the Sun and its various phenomena, with a focus on understanding the solar atmosphere, solar magnetic storms, and their impact on the Earth's environment. In this article, we will delve into the details of Aditya L1, its objectives, history, scientific instruments, and its potential significance in the field of solar and heliophysics. Mission objectives. The primary objectives of the Aditya L1 mission are as follows. Study of solar upper atmospheric dynamics. Aditya L1 aims to investigate the dynamics of the solar upper atmosphere, specifically the chromosphere and corona. These regions of the Sun are of great interest to scientists due to their unique properties and behavior. Understanding chromospheric and coronal heating. One of the central puzzles in solar physics is the question of why the Sun's corona is much hotter than its surface. Aditya L1 will focus on studying the heating mechanisms of the chromosphere and corona, shedding light on this enigma. Observation of in situ particle and plasma environment. The mission will provide valuable data on the in situ particle and plasma environment around the Sun. This data will help scientists better understand the dynamics of particles originating from the Sun. Physics of the solar corona. Aditya L1 will contribute to advancing our understanding of the physics of the solar corona, the Sun's outermost layer. This layer plays a crucial role in solar phenomena and space weather. Diagnostics of the coronae and coronae loop plasma. The mission will measure temperature, velocity, and density in the coronae and coronal loop plasma, providing critical information for solar research. Development and dynamics of coronal mass ejections, CMEs. Coronal mass ejections are powerful solar events that can impact space weather. Aditya L1 will study the development, dynamics, and origin of CMEs, aiding in their prediction and mitigation. Magnetic field measurements in the solar corona. Understanding the magnetic field topology and measurements in the solar corona is essential for comprehending solar behavior. Drivers for space weather. The mission will investigate the origin, composition, and dynamics of the solar wind, which is a key driver of space weather events that can affect Earth's technology and infrastructure. Mission history. The concept of the Aditya mission began in January 2008 when it was initially envisioned as a small, low-Earth orbit (LEO) satellite weighing 400 kg. Its primary purpose was to study the solar corona using a coronagraph. An experimental budget was allocated for this mission in the financial year 2016-2017. Over time, the scope of the mission expanded, leading to the development of Aditya L1. This comprehensive solar and space environment observatory was designed to be placed at the L1 Lagrange point, which is about 1.5 million kilometers from Earth. As of July 2019, the mission had an allocated cost of 78.53 crore rupees, excluding launch costs. Overview of the Aditya L1 mission. The Aditya L1 spacecraft is positioned in a halo orbit around the L1 Lagrange point, which is situated between the Earth and the Sun. This orbit is approximately 1.5 million kilometers, 930,000 miles from Earth and allows for optimal observation of the Sun. The spacecraft will remain in this halo orbit for its planned mission duration, with a station-keeping cost of 0.24 meters per second per year. The spacecraft itself weighs 1,500 kilograms, 3,300 pounds, and is equipped with 7 scientific payloads. These payloads are designed to address various aspects of solar research, including coronal heating, solar wind acceleration, coronal magnetometry, and more. Additionally, Aditya L1 will provide in situ characterizations of the space environment around Earth, measuring energetic particle fluxes and magnetic fields of the solar wind and solar magnetic storms. One of the central challenges in solar physics is the significant temperature difference between the upper and lower layers of the Sun's atmosphere. While the upper atmosphere can reach temperatures of 1 million K, the lower atmosphere is much cooler at around 6,000 K. Aditya L1 aims to obtain simultaneous images of different layers of the Sun's atmosphere, providing insights into the energy transfer processes between these layers. The mission holds the promise of addressing some of the most significant questions in solar physics and heliophysics and advancing our understanding of the Sun's behavior and its interactions with Earth and the space environment. Payloads on Aditya L1. The instruments on Aditya L1 can be categorized into two types: remote sensing payloads and in situ payloads. These instruments include remote sensing payloads. Visible emission line coronagraph, VELC, used for coronal imaging and spectroscopy. Solar Ultraviolet Imaging Telescope, SUT, provides images of the photosphere and chromosphere in narrow and broadband. Solar Low Energy X-ray Spectrometer, SOLEXes, a soft X-ray spectrometer for Sun as a star observations. High-energy L1 orbiting X-ray spectrometer, HEL1OS, a hard X-ray spectrometer for Sun as a star observations. In situ payloads. 5. Aditya Solar Wind Particle Experiment, ASPEX, analyzes solar wind and particle properties, including protons and heavier ions with directions. Plasma Analyzer Package for Aditya, PAPA, examines solar wind and particle properties, including electrons and heavier ions with directions. Advanced Tri-Axial High-Resolution Digital Magnetometers, provides in situ magnetic field measurements, BX, BY, and BZ. Development of payloads. These scientific payloads have been developed by various Indian laboratories across the country in collaboration with ISRO. Each payload is specialized for specific scientific investigations related to solar phenomena, significance and potential discoveries. The Aditya L1 mission holds immense potential for advancing our understanding of the Sun and its interactions with Earth and the space environment. Some of the key areas where it can make significant contributions include coronal heating mechanism, solving the mystery of why the Sun's corona is hotter than its surface. Space weather prediction, improving our ability to predict space weather events and their impacts on Earth's technology. Solar wind and magnetic field studies, enhancing our knowledge of the solar wind and its interaction with Earth's magnetosphere. Understanding Earth's climate, investigating how solar variability affects Earth's climate over long time scales. Comprehensive solar atmosphere imaging, providing multi-wavelength observations of the Sun's atmosphere. Origin and dynamics of CMEs, better understanding of coronal mass ejections and their potential effects. Launch. The Aditya L1 mission was successfully launched on September 2, 2023, at 11:50 am IST. The spacecraft was injected into its intended orbit approximately an hour later, at about 12:54 p.m. IST. The next phase of the mission, an Earth-bound burn, is expected to take place on September 3, around 11:45 IST. In conclusion, the Aditya L1 mission represents a significant step forward in India's space exploration efforts and solar physics research. With its advanced instruments and ambitious objectives, it has the potential to unlock new insights into the Sun's behavior and its impact on our planet and beyond.